Hi everyone. All right, let's talk some chemical equations, right? Let's start with this slide. We have two types of chemical reactions. We have exothermic and endothermic reactions. Exothermic give off energy. They give off light, they give off heat, they give off a little bit of smoke. Exothermic is all about chemicals reactions that give off energy. Now endothermic is the opposite. Endothermic, you take energy in. You get colder. Everything feels cold to the touch as heat is going in to the reaction to make it work. That's what we see in this picture right here. These little arrows are pointing in, and that means energy is going in there. That would make this container feel cold. The exothermic reaction, though, that would cause this container to feel hot because we see energy coming out. Now, those are two types of reactions. Let's talk something more interesting. Let's talk about chemical reactions. So before we talk about chemical reactions and how to balance them, we need to figure out what a chemical equation is. And all a chemical equation is that it describes a chemical change. And we've got a couple of parts to a chemical equation. We have the beginning and the end. The beginning is what we will call the reactant. The reactants are whatever you start with. They're on the left side. On the right side, we have the products. The products are whatever you end with. They're whatever you created out of this chemical reaction. So the products are on the right side, and the reactants are on the left side. Now, we don't just have reactants and products. We also have the middle. The middle is called the reaction symbol, and the reaction symbol carries over the reaction. It symbolizes the reaction itself. So the other thing we need to remember about this is we also have subscripts and coefficients. Subscripts are the very tiny number here that we see, that little 2 here, little 2 in H2O, that's a subscript. A subscript shows you how many atoms of an element are in a molecule. So in this case, we have 2 hydrogens and 1 oxygen. There's no number here, so it's implied that it's 1. Coefficients, on the other hand, are in small numbers. They're big numbers like this that go in front of the actual molecule. And it tells you how many molecules there are of a particular chemical. So here we have 3 molecules of water. So in 3 molecules of water, we have a total of 6 hydrogens. 3 times 2 is 6. And we have a total of 3 oxygens. 3 times 1 is 3. So we have 3 water molecules. All right. Now that we can read a chemical equation, let's talk about a law of chemistry. A law of chemistry that is important to us for this test is the law of conservation of mass. Now this says that in a chemical reaction or equation, matter is not destroyed or created. It is just changed or transformed. And when a chemical equation is following this law, we will call it balanced. Now, I know a lot of you guys have panicked about, oh, I don't know how to balance a chemical equation. And, you know, that happens in the beginning. Don't give up, though. There's a couple of rules that I recommend following, and then you got to practice it a little bit, right? We'll practice it some together. So, rules of the game. Matter cannot be created or destroyed. So, that's our first law, right? Subscripts cannot be added, removed, or changed. So those little numbers, we can't change those. Those stay the same. You can only change coefficients. All right, so that's good news for us. We can change the big numbers in front of the molecules. And remember, coefficients only go in front of the chemical formulas, never in the middle or the back. I always recommend balancing big molecules first, and always try and do it an element at a time. All right. So let's balance some equations here. So this is, look at that 2. That 2 has moved a little bit. So this right now is a balanced chemical reaction, right? So let's look at it unbalanced. Ooh, let's see if it loads. Oh, good, it loaded. All right, so here's our unbalanced chemical equation. The first thing you should always do is this. Write a reactant side and a product side. And then you should fill in what you have. So for example here, we have nitrogen and we have hydrogen. And we should fill in how many we have of each. We have 2 here, so we write 2. we have 2 hydrogens. All right, and we write 2 here. These are reactants. For our product side, we have 1 nitrogen and 3 hydrogens. Now we need to balance. All right, so we have only 1 here, so we can only change the coefficients, right? So if we put a 2 here, then we have 2 on both sides. All right. If we put anything else, it's going to unbalance it. So for right now, nitrogens are good. Now let's look at the hydrogens. Hydrogens, we have 2 here, and we now have 6 here. 2 times 3, that's 6. So if we wanted to make the hydrogens equal, we're going to have to make 6 hydrogens appear on the reactant side. And remember, we can only change the coefficients. So if we put a 3 here, we get 3 times 2, and that puts 6 on this side. All right, let's do that one more time. KClO3 it decomposes into KCl plus O2. So we always start the same. First, reactants and products. And now we need to write down how many we have of each. So we have 1 potassium, we have 1 chlorine, and look at this subscript here. That tells us we have specifically 3 oxygens. Then now let's look at the product side. We have 1 potassium, 1 chlorine, and this subscript tells us we have 2 oxygens. All right, so let's balance. So potassium and chlorine are good. So we just need to balance the oxygens here, right? So in order to balance this, we're going to have to find the least common denominator here, right? We're going to have to find something that both 3 and 2 can divide into. And the best thing they can both divide into is 6. So, excuse me. It's early in the morning. So, to make both sides equal 6, I'm going to have to add a 2 here and a 3 here. All right, my 3 moved a little bit. That 3 should be here. And that makes 2 potassiums now, 2 chlorines, and 6 oxygens. And on this side, we now have 6 oxygens. But look, now our potassium and chlorine are off. So if we put a 2 right here, that would make them all equal. All right, so let's get out of my big view here. So those are examples of chemical or balancing chemical equations, right? So I've got one more slide that's important for us, and it's this slide. You should know this slide. Know that if there's an S in the equation, that means it's solid. If there's an L in the equation, that is liquid. And if there's a G in the equation, that is a gas. AQ means aqueous. It means dissolved into. You should know these things, and on the test I could ask you which one of these in the formula is a solid, which one is a liquid, and you'll have to look for these symbols. Alright, that's it for this video. Great job, everyone. Good luck on the test, good luck studying, and I'll see you tomorrow. Bye, everybody.